Webb Telescope has been hit. Its primary mirror was damaged by 6 micrometeoroids, one of which left a significant mark. Scientists expect these tiny rocks to hit here and there, but this one turned out to be worse than first thought. While NASA initially did not consider the damage to be significant, the new report states that it could be more severe than expected. The 6th micrometeor strike reportedly did considerable damage and has left scientists questioning the life of the James Webb Telescope. Is it about to crash? Is the $10 billion experiment going to end soon? Stay tuned till the end to find out. Hello and welcome to the Beyond, where we take you on exciting rides into the cosmos. For more interesting content like this, don't forget to like and subscribe to our channel. Having said that, let's get on with today's video. The James Webb Telescope has been in orbit for 6 months now, carefully aligning its mirrors so it can start beaming down images of our spectacular galaxy. But space is a rather dangerous place, and meteorites are common. And as scientists begin the next stage of the mission, getting the telescope ready for science, dangers still abound. One of the most probable things to cause the Webb damage now and for the entirety of the mission? Pieces of space dust weighing less than a gram. Between May 23 and 25, the telescope was hit with micrometeorites impacting one of the 18 hexagonal golden mirrors of the observatory. While NASA initially did not consider the damage to be significant, the new report states that it could be more severe than expected, as the 6th micrometeor strike reportedly did considerable damage. It was not until June that NASA disclosed the micrometeoroid strike and noted that the debris was more sizable than pre-launch modeling had accounted for. As a result, the damage caused by the tiny rock fragment is producing a noticeable effect on the observatory's data. Fortunately, this change is not incredibly impactful on how the telescope functions. After all, NASA has said that its performance is continuing to exceed expectations. But as is expected, it fundamentally reduces the accuracy of the data collected. On the 12th of July, scientists on the mission shared an image that shows just how bad the damage resulting from the impact is. It is contained in a report that contains the details of the mission, including what has been discovered using the observatory in its first 6 months in space. NASA has said in a statement after the asteroid hit the James Webb Space Telescope's mirror was engineered to withstand bombardment from the micrometeoroid environment in its orbit around Sun-Earth L2 of dust-sized particles flying at extreme velocities. The 6th strike was caused by a larger micrometeoroid and resulted in what has been described as a significant uncorrectable change to segment C3, causing a considerable blemish to the segment. Like any spacecraft, the telescope has encountered micrometeoroids and its sensors have detected 6 deformations on the telescope's primary mirror panels that have been attributed to strikes. The strike has caused some concern about the impact that future strikes of these larger micrometeoroids might have. However, NASA considers there could be a chance that this early strike on the James Webb Telescope may just be an unlucky one by a high kinetic energy micrometeoroid that statistically occurs only once in several years. Micrometeoroids are a known danger of space operations, and facing them is by no means new to scientists. The International Space Station and the Hubble Space Telescope are among long-running programs that are still operational despite occasional space rock strikes. However, Webb's orbit at Lagrange Point 2, about 1 million miles away from Earth, may change the risk profile considerably. Webb engineers first detected deformations on the primary mirror during the commissioning period during the alignment, or in technical terms, the wavefront sensing phase. In this phase, they put the 18 segments of the hexagonal mirror into the best position to capture light. With the highly volatile cosmic environment while hurtling meteors and space rocks, the scientists were prepared for the James Webb Space Telescope to be hit at some point. But maybe not this early and not this much damage. The scientists pointed out in the report that the JWST suffered what they described as a small effect throughout that is not yet measurable. They also mentioned that the largest source of uncertainty is the long-term effects of micrometeoroid impacts that slowly degrade the primary mirror. Here is how the main mirror is assessed. The main mirror performance is evaluated by how much it deforms starlight, and it is measured using what scientists call wavefront error root mean square. When Webb's mission began, the affected C3 segment had a wavefront error on 56 nanometers root mean square, which was in line with the 17 other mirror portions. After the impact, however, the error increased by over 4 times to 258 nanometers root mean square. But realignments to the mirror segments as a whole reduced the overall impact to just 59 nanometers root mean square. For the time being, the team wrote that Webb's alignment is well within performance limits, as the realigned mirror segments are about 5 to 10 nanometers root mean square above the previous best wavefront error RMS values. This is a reason why such strikes are a bigger concern with Webb than the Hubble Space Telescope. Webb carries an abnormally large mirror to take high-resolution images of objects far in space, but it was not possible to put the mirror inside the spacecraft, so instead it was kept on top of the Space Telescope and unfolded systematically once it was in space. And this is why Webb's mirrors are always exposed to external damage, and there cannot be any protective sheath for it. Based on fuel usage, the telescope should last 20 years in space, but scientists were not sure how much of an effect a micrometeoroid strike would have upon its operations, as the author's report stated. So, how do the errors from the mirrors impact the calculations? NASA said that each micrometeoroid caused degradation in the wavefront of the impacted mirror segment as measured during regular wavefront sensing. But some of these degradations are correctable by adjusting the math that applies to the data that each panel collects. The JWST was launched on Christmas Day of 2021. It comprises one of the largest mirrors on a space telescope. NASA built it at a cost of $10 billion in collaboration with the European Space Agency and the Canadian Space Agency. It had barely justified its cost before the huge loss. How can an incident like this be prevented from happening again in the future? NASA released a statement that reads, their project team is conducting additional investigations into the micrometeoroid population and how impacts affect beryllium mirrors. Another potential method to reduce the number of micrometeoroid strikes could involve limiting the amount of time that Webb spent looking in the direction of orbital motion, which statistically has higher micrometeoroid rates and energies. Can the Webb telescope be repaired? As per NASA, the James Webb Space Telescope will not be serviceable, but it has been designed to be reliable without regular servicing, and a growing amount of orbital debris has regularly forced the International Space Station's controllers to carry out what they call avoidance maneuvers to prevent the station from being hit. Engineers are still modeling how frequently such events will occur. The team wrote it is not yet clear whether the May 2022 hit to segment C was a rare event. By rare, they said it is possible that they happen to get a high-energy impact that could statistically happen only once every few years. Modeling is currently ongoing to estimate the hazardous population of micrometeoroids and to figure out remedies such as restricting pointing direction. For now, engineers are keeping an eye on potential future dust-generating events such as in 2023 and 2024, when Webb is expected to fly through particles left behind Halley's Comet. NASA's Meteoroid Environment Office at the Marshall Space Flight Center in Huntsville, Alabama, is modeling the impact risk to Webb associated with Halley. NASA currently tracks more than 27,000 pieces of space junk, although it says there is much more debris, especially those that are too small to be tracked but still large enough to threaten human spaceflight as well as robotic missions. Quite tricky. NASA adds there are 500,000 pieces of debris the size of a marble or larger that is up to a centimeter or a half-inch wide, and approximately 100 million pieces of debris about 0.04 inches or a millimeter and larger. There is even smaller micrometer-sized debris that is 390 thousandths of an inch in diameter, and all that can pose a risk. Even tiny paint flecks can damage a spacecraft when traveling to velocities of up to 17,500 miles per hour, fast enough to go from London to New York in 12 minutes. How do you think further micrometeoroid disasters can be prevented? Let us know in the comments section below. And that's a wrap. Thanks for watching. Be sure to like and subscribe to our channel for more interesting content like this, and turn on the notification bell to never miss any exciting updates. And we'll see you in the next one.